Hello, how are you doing? Today is January 9th. January 9th. I should write this somewhere. January 9th. It's a rainy day and it's been windy. I don't know about you guys, but the first windstorm we had earlier last week blew off and completely destroyed one of my outbuildings, horse shelters, and ripped the roof off of, or at least the tiles off of my shed. And then the last windstorm ripped up and blew away the other outbuilding, and both times I had my tractor underneath each one. The first one, it blew off the outbuilding and actually tipped over the tractor. Got that all fixed up, put the tractor in the second one, and then blew that. I have run out of outbuildings. Spent all day Sunday cleaning up, disassembling those, and getting them stacked into piles. And the tractor somewhere over by my barn. And of course, we had two big trees go down on fences. So if you're not at school, I get it. You're probably working. And plus, it's raining like crazy now. So I'm going to introduce to you this concept of what we're going to do second semester. This will be the main thing we do. It's going to take us a semester to really nail this down. If you remember the first semester, what we did was talk about linear equations. In other words, there's relationships where if this goes up, then that will go up, or if this goes up, then that one will go down. Those are called linear relationships, and then you can represent them on a graph by drawing a line. And so we learned to start with how to move things around the equal sign, and then eventually got to where we understood the basic equation of a linear equation, what that looks like. Well, not everything goes in a straight line. We do quadratic equations. So today I've got four things. First of all, what is a quadratic equation? How do you recognize it? What do they use for? And how do you show it on a graph? We won't get to all that today. It's going to take us pretty much the whole semester to do this one little thing. Probably 5 months left in the year here at school. We'll spend four of them, 3.5 at least, on this particular issue. So I'm going to talk about what is a quadratic equation today and how do you spot patterns in quadratic equations. We will actually go into your little workbook today, and the homework for a while will be from the workbook, so it'll be kind of easy. You have lots of practice problems on it. And here's the deal. All right, so let's start with linear. A linear equation fits into generally this formula. Something y equals something times x plus something. And this is the slope, that's m, and this is the y-intercept if you were to draw that on a graph. And if you know this slope and the y-intercept, then you can draw the line. And so we worked on that. It can also be written as ax plus by equals c. That is something times x plus something times y equals something. There's a couple of different ways to write this. This is called the standard form. This is called the I'm going to graph it form. Graphing it is the most useful. The standard form, not so useful. There are reasons you would use it. For example, right before Christmas, if you put something in a standard form, two lines, and you wanted to know where they crossed, you could use that concept called elimination or substitution. Works really well in standard form, much more difficult to work with in this form. This is graphing, and this is, again, what we call standard form. Well, and these are lines. Okay, you knew that. Now, that's your review. I'm not going to spend any more time on lines now. So congratulations, you just graduated from lines to curves. Curves are what we would call wavy things instead of straight things. Not every curve is a particular kind of curve. Um, if you've heard this term before, parabola or parabolic, that is a quadratic equation. That is the second type of equation that you generally study in algebra. The most common is lines. The second is parabolas. Well, what's with the parabola? What's a parabola look like? A parabola looks somewhat like a U. It can be a sideways U, an upside down U, a left sideways or a right sideways U. And it's not exactly a U because it goes in and then out. Generally in Algebra 1, we focus on those. We don't worry about, well, what if you flip it over? What if you turn it left? What if you turn it right? We're going to focus on this one because once you know one, you can just do with this minor modification. In other words, if you put a negative sign in front of it, it becomes an upside down. If you exchange y for x, it becomes this. If you put a negative sign and you exchange y for x, you get that. So we're going to focus on this. And once you get this, those will come later. So again, what is a quadratic equation? It's a parabola. Okay, why is it called a quadratic equation? Well, quad means what? 4. That's because in standard notations, you have something times x squared plus something times x by itself plus something else equals y. Okay, this is called a quadratic equation, where you'll notice that it's very similar to the standard equation, but you have an x squared. And because you're putting more stuff, we just, kind of go A, B, and then whatever ever left is C. Okay, in this one, ax plus bx squared, x squared plus bx plus c equals y. 1, 2, 3, 4. That's a quadratic equation. Now, what if b is 0 and c is 0? It's still a quadratic equation. So that's one of the things that we're going to look for today, is how to recognize a quadratic equation. In graphing form, it looks a little bit different, and I'm not going to show you what that looks like today because I'll just confuse you. We're going to focus on standard form stuff today, and show you what that means. What we're going to do in this class is we are going to basically try and make it to where we are saying, what if this equals 0, and then solve it? What does that mean? Well, I'm going to draw a picture. So let's say, for example, I have a parabola. Looks like that. Okay, this is your x-axis and this is your y-axis. Well, this is what a quadratic equation looks like, or parabolic equation looks like. What if y was 0? What would x be? You'll notice y is 0 is this line here. Y goes 0, 1, 2, 3, 4. So right when it hits this axis, y is 0. Well, where y is 0, you've got 2 spots here. So there's 2 answers to that equation. So if I set y to equal 0 and I say solve this, what I'm asking you to do is I'm saying, what are these 2 spots? If y is 0, what's x? So again, solve in a quadratic equation means if y is 0, then what is x? Or in this case, there's 2 of them. So what are x? So if y is 0, then what is or are x? In this case, I've got 2 things. Well, I don't know. I just drew a random thing, so I can't answer that question here. But every quadratic equation has solutions, sort of. So let's start with, you will generally not see this for a couple of months. What you will see is ax squared plus bx plus c equals 0. That's what you'll see. And then you'll see an equation that says solve. And what I mean by that is what? This is a parabola where y is 0. So I've got 2 spots. But is it, you ask yourself? Is it? The answer is no, it isn't. So what do I mean by that? Well, this is what I mean by that. I want you to imagine there are a parabola on your basic XY graph. Again, there's X, there's Y, and you have a parabola. Okay, it helps to have sound effects. I do not want you ever at home drawing a parabola without saying whoosh. Okay, very important. So this has 2 X's. That has 2 solutions. Now, what if you have a parabola that just touches right on the edge. How many solutions does it have when I say it's equal to 0? The answer is it's only got one. So this is two solutions. This is one solution. It's just got one. And so when you say solve this quadratic equation, there's a couple possibilities. It depends on what kind of parabola it is. Is it one that, think of it as like the ocean? It goes under the ocean, it comes back up. It's like a diver coming back up, but then he flies. Whee! And if he goes up, you must use the word we. And then it goes down, you're going, ah. So it goes, ah, splash. Whee! So every time you draw one of these, I want you to say, shh. And if you can't do that, if you have more time, I want you to say, ah, blah, 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 wee. That's important. In this one, he goes, ah, wee, because he just splashes in one spot. Doesn't even go underwater. Just hits it like a big giant slap. And yeah, like you'll do if you do this in front of your parents while they're trying to have a conversation. So they will slap you. All right. The third option is what I'm going to call a floater. And it goes, whoosh. In this case, it's owie. And it sounds like owie, but it's not really. It's owie. So I just go with sh as opposed to owie. Anyway, it floats. So if I give you this equation, it's got two solutions. So if I give you this one, it's got one solution. And if I give you this one, it doesn't have any solutions. You can't solve it, in other words. So if I were to draw it, it makes it really easy to picture what's going on. When you're seeing them in real life, they look like this. 8x squared equals 6x squared plus 5x squared. And you say, what is that? And you answer yourself, I don't know. I'm in algebra. I'm taking a class. You're supposed to tell me that. And you're right. I am. So you have an equation like that. Or sometimes you have ones that look like this. 8x minus 7x squared equals 2x plus 4x squared. And you say, oh no, what is that? How do I do that? I don't know. You're the teacher. You tell me. Aha, this is where we come back to why we started the year the way we did. Learning how to move things around the equal sign. What you're ultimately trying to do is to get it to where it says something times x squared plus something times x plus something. I call it C, B, A, equals 0. So if I look at this, and I'll do this one as an example, I have 8x squared equals 6x squared plus 5x squared. Well, okay, if going back to Hatman or anything else, if I have 8 Hatman, in this case a Hatman is an x squared, equals 6 Hatman plus 5 Hatman, can I add these two together? The answer is yes, because they're the same. 6x squared plus 5x squared is how many x squareds? So I'm going to do that. So I'm going to end up with 8x squared equals 11. Oops, that's 10. 11x squared, right? Now, I want to end up looking like this, where everything on this side is 0. So how do I get that to 0? Well, what if I subtract 11x squared? But I have to do that to both sides. So I end up with negative 3x squared equals 0. Y'all with me on that? Okay. Now I have solved this problem. Now, so if I look at this, negative 3x squared equals 0. Okay, so what's A in this case? Well, it's negative 3. What's B? 0. And what's C? 0. So this is a quadratic equation because it has all these parts. It's just that B and C are 0. It's got an x squared. In your head, you think, oh, if it's got an x squared, it's probably a quadratic equation. But there are other things with x squareds that are not quadratic equations. So at this point, you haven't seen them. So be thinking, oh, it's got an x squared. It's probably quadratic. Let's see if I can put it into this form. And now I get to here, and I say, okay, I want to get what x squared is. Well, x squared equals, we'll divide both sides by negative 3. What's 0 over negative 3? The answer is 0. So what times itself is 0? X squared means x times x, right? Well, x times x is, how about 0 times 0 equals 0? Yeah, that works. Does anything else work where you times it by itself and you get 0? The answer is no. So the solution to this is x equals 0. And I circle it and I say, yay. So I go back to my pictures. What does this parabola look like? Well, does it have two solutions? No. Does it have no solutions? No, it has a solution. It must be this one. And what is that solution? Well, that is where y is equal to 0, x is equal to 0. So this parabola looks like that. And it crosses right there at the 0. So where y is equal to 0, it crosses at x equals 0. It's at the 0, 0 point. That's the solution to this thing. Now, that seems pretty easy when it's equal to 0. But the hard part is looking at these things and going, oh my, what do? I don't know what to do. It's very hard. I don't know. What should I do? Well, they don't all look like this. Let's look at this one, for example. Here, I'm going to switch to a new page so that way it's obvious. Second. Okay, that's 8x minus 7x squared equals 2x plus 4x squared. Okay, what am I asking you to do? Number one, put in standard form. What that means, something times x squared plus something times x plus something equals 0. Does that look like that? The answer is no, it does not. It's got x squareds, it's got x's, so I got to make it that way. So the first thing you do is you look, can I combine anything on any one side like I did on the last problem? In this case, I have an x squared and an x. I can't combine that. That's like 8 hat men minus 3 toaster heads, or 7 toaster heads. A toaster head and a hat man are different. Again, that's different than that. So you cannot combine them. I have 2 hat men and 4 toaster heads. I cannot combine them. So the first step is combine them if you can. I'll write that down. Combine if you can. Okay, you can't. So there, too bad. Okay, second is move everything to the left. Okay, well, how do I get rid of this 2x? Subtract 2x. How do I get rid of the 4x squared? Subtract 4x squared from both sides. And then these go away. 2x minus 2x. So notice I didn't write underneath it. It's just like that. And so I'm going to then, well, what's 8x minus 2x? It's going to be 6x. What's negative 7x squared? Minus 4x squared. Well, that's minus 11x squared. Okay. It's much closer to this than I was before. So combine if you can, move everything to the left. When you do so, you'll end up with something that's usually pretty good. Now all you have to do is just put it in the right order. So that's negative 11x squared plus 6x plus 0 equals 0. I usually don't put this part in here because there's nothing else there. So this becomes just negative 11x squared plus 6x equals 0. But notice this is that form. To put it in standard form, what do? 1, combine if you can. 2, push everything to the left. 3, arrange. So all I did in this one is I just flipped them. Ooh, that's pretty good. Anyway, so I just flipped them. So your homework today is going to be just doing that. You're not going to solve this at all. All you're going to do is you have a bunch of problems and I want you to put them in standard form. Okay, we will learn about how to solve them on another day. But at first, you're just putting them in standard form. That's going to be your homework, and you're going to do it a bunch of times. So your homework is going to be on page 56 through 50. I think I'm going to have you do 58. Okay, so that's 3 pages. 3 pages. And what you're going to do is put in standard form. Okay. Okay, going back to where did we start our day? Well, what is a quadratic equation? Well, it's a mathematical equation that when you graph it, it looks like a parabola. How do you recognize it? Well, it's got this form if you arrange it into that form. So if it looks like that, and again, remember um, A has to be a number. If it's got 0, then it's just a line. Okay, so it's not a quadratic equation. So you've got to have an x squared. B and C could be zeros, or they can be numbers. And what are they used for? The answer is there's a lot that they're used for. I haven't talked to you about it today, but the universe is pretty well set up to where a lot of things function with squareds. For example, the power of gravity is something to the second power equation. Electromagnetism, how strong things are attached, are something to the second power. Anything that has to do with expanding waves is something to the second power. So you've got a lot of things that are to the second power. So that's why it's one of the first things that we study in algebra. Not the first thing, but usually the second. And that's it. And how do you show it on a graph? We'll show you some other day. You can at least know that there are 3 types of parabolas: ones that cross, ones that don't, and ones that just hit it in one spot. If I set y equals to 0, what I'm really asking for is where does it cross? Okay, that's the end. Have fun. It's good for you. See you later.